All right, so in this video, what we're going to do is we're going to be actually graphing these without using any sort of table. Instead, we're going to be using the information that we already understand and know from graphing trig functions previously. So what this is saying right here, if I was given r equals cosine theta, I'm going to go ahead and graph that over here using this right here as an xy graph. And so cosine, remember that that starts at 1, goes down to -1, comes back up to 1. So what I'm going to go ahead and have here is this would be pi, this would be my 2 pi, and right here where it crosses is going to be 3 pi over 2, and right here where it also crosses is going to be pi over 2. So I'm going to have these values right here. I'm going to go ahead and split these up by quadrant. So I'm going to graph 0 to pi over 2. I'm just going to graph just that part right here, and I'm going to go right here as I'm going around. Now, if I start at 0 radians, my cosine graph, as my parent function, goes up to 1, and it goes to -1, right? So at 0 radians, I'm at 1. So that means, and for the sake of just, size on this video, I'm going to call this ring out. I'm going to call 4 rings out 1. So what we're going to do here is this would be at 1, 0 radians. So that's my coordinate, right? Because if I did this as a polar coordinate, this would be 1, 0, because it's r theta, okay? Here at pi over 2, my r theta there would be 0 pi over 2. So if I plot that, 0 pi over 2 puts me right here, okay? Now, if you think about what you have here, if I'm going from 1 down to here at 0, this is the length of my r, the length of my radius. It's getting smaller and smaller, right? So if I'm starting here, that means my radius as I go around to each angle, it's getting smaller and smaller. So it's kind of getting sucked back into that pole right here. So now what I'm going to do is do my second quadrant. So my second quadrant would be from pi over 2 to pi. So it's just going to be these values right here. So I'm picking up right where I left off right here at 0 pi over 2. My polar coordinate right here at pi would be -1 pi. Well, pi is over here, but it's a -1 for my r. So that means instead I'm going to be over here, right back where I started, aren't I? And so as I look right here, my r, as I'm going from pi over 2 to pi, it's getting larger, right? So if I think about my larger r values, those are further and further out, right? So as I get larger in my angle measure, my r value is getting further and further away from the pole. So in summary, as I'm going from this maximum down here to the x-axis, my r is getting closer to the pole. As I'm going right here from pi over 2 to this minimum, so as I'm going from where it goes across the x-axis to a minimum, my r is getting larger and larger. The distance from my pole is further and further. A good rule of thumb and a way to think about things is right here, this x-axis, think of that as the pole, okay? So as my point gets closer to the pole on here, as it gets closer to the x-axis, it means it's getting closer and closer in. It's going in this way, towards the pole. And as I go further and further away, like I do here, I'm moving further and further out, okay? So let's kind of see what we have for our next one. So here, I'm going to be going up to 3 pi over 2. At 3 pi over 2, my polar coordinate would be 0, 3 pi over 2. Well, 0, 3 pi over 2 is plotted right here at the center. So I already have a point there, and I'm here. So that basically means, not even basically, that just means I've just overlapped that red one right there. Okay, they're exactly in the same spot. And then I can go ahead and do this one right here. And that would be from my 3 pi over 2 to my 2 pi. My r value at this one is 1, so I'm at 1, 2 pi. Well, if I did that, 1 and 2 pi puts me right here. So this overlapped as well, didn't it? So cosine theta is just going to be a circle over here. It's going to be symmetric across my x-axis. Okay, my r value, so whatever I have out front here for my a, is going to represent my r that I'm doing here. Okay, so important thing to take away from this is that crossing the x-axis is equivalent to moving through the pole. Okay, a negative y value is equivalent to moving away from the angle and polar. And that's what we saw over here, because if I have these values here, I had a negative r, and that was supposed to be my second quadrant. Were any of those in my second quadrant? Nope. They were all over here in my fourth quadrant. So just kind of keep that in mind. Anytime that I have a part of my graph over here below the x-axis, it means it's in the opposite quadrant, pi away from the one that you're actually looking at it to be in. All right, let's try this one. If I have sine theta, okay? So if I graph sine theta, just like we learned how to do earlier, this would be 1, negative 1, and it would go from the origin up, down, and up, right? And I'd have pi over 2, pi, 3 pi over 2, and 2 pi. And those are each of my quadrants. So I'm going to make this a little bit thicker. And so here, I'm going to be going from 0 to pi over 2. Okay? If I do 0 to pi over 2, my polar coordinate here at pi over 2 is 1 pi over 2. And my polar coordinate here at 0 is 0. That one's 0, 0. 0 for my r, 0 for my radian measure. So I'm going to start here at the pole. And at pi over 2, I'm going to go out to 1. And again, just like on the last one, I'm going to call 1 these 4 circles out. So basically, we're going by 0.25 around the circle, right? That's what we're doing here. Obviously, I'm not going to have any decimals, but that's what we're doing. Okay. And so now I'm going to go ahead and connect those dots. Now, 0 to pi over 2, that's my first quadrant, right? So I've got to connect these 2 dots through my first quadrant with a curvy shape, because as I'm going from 0 to pi over 2, my r value is doing what? It's getting larger. So I've got to go out to get that. Let me draw that a little bit better. Okay, so I get that. All right, let's do my next one. So I'm going to go from pi over 2 to pi. So this is what I've got here. So my polar coordinate here is 0, pi. Well, 0 pi is back at the pole right here. So that means I'm going to be taking this one, because as I'm going here, my r value is getting smaller. So I'm getting closer and closer to that pole, that origin here. I'm getting closer to it as opposed to getting further away from it. So that's what I've got here for this one. And now, just like the last one for cosine theta, if I get down here in this quadrant, if I go here, I'm going to end up at 3 pi over 2 with a negative 1r, which is going to put me right back here. So this one actually repeats after this one cycle, just like cosine did. The difference here is that sine is symmetric about my y-axis, whereas cosine was symmetric about my x-axis. All right, let's see what we have down here with this one. So for this one, I've got cosine minus 1. So let's graph that. If I do cosine minus 1, what does that minus 1 do if I was to graph that over here? I'm sorry, that just looked terrible. How is that going to look if I graph that over here? Well, that negative 1 means that instead of being through my x-axis as my midline, it means my midline is now at negative 1. I'm going to put that a little bit further down. That's my midline here at negative 1. And remember, my maximum and my minimum is found by just taking the value that I have here at the end and adding my absolute value of my A and the absolute value of my A being subtracted from that. So it'd be -1 plus 1 and -1 minus 1. So that's going to get me 0 and -2. And this is cosine, so that means I'm going to be starting here at 0, and I'm going to be going down and then back up. So, and I'm going to go ahead and I'm just going to draw my midline through here. So right here is going to be my pi over 2. Here's pi. Here's 3 pi over 2. And here is 2 pi. Okay. So I'm going to go ahead and figure out what I've got for each quadrant. So I've got 0 to pi over 2 right here. 0 to pi over 2, this polar coordinate right here is going to be 0, 0. And this polar coordinate right here is going to be -1 pi over 2. So let's plot those. 0, 0 is right here. -1 pi over 2 is, well, here's pi over 2, but I got to do -1. So I'm going to call 1 2 rings out so that I can go to 2. The reason I'm doing that is because I can see I'm going to need to be out at -2. So I'm giving myself at least the room to be able to do that. So right here, I'm going to go to pi over 2, -1. So that means I'm going to be right here. I'm going to be at 1, but 3 pi over 2, right? Because this is going, -1 is going away from pi over 2. I'm going in the opposite direction. All right, so if I'm going to graph those, let's think about what I have here, and I have to connect the dots. The hard part is, okay, am I going like this? Am I going like this? Which way am I going? So what I do when I do these, I think about it this way. This is all quadrant 1, right? I've not had a phase shift or anything on my graph, so the only way I can have something that's not in quadrant 1 will be if I have a -r, and that means instead it's going to be in its counterpart over here in quadrant 3. So I'm going to connect these this way. So I'm going through quadrant 3. All right, and then let's do this one right here. So now I'm going to go from pi over 2 to pi. So at pi, my polar coordinate here is -2 pi. Well, -2 pi, so here's pi over here. It's going to be -2 though, so it's going to be here. Okay, and so now I'm going to connect these. Again, the reason I know I'm going through here from this point to this point, I'm going out. I'm not going like this. I'm going to be going kind of down and out a little bit. And that's because as I'm doing this, I'm getting further and further away from the pole. So you can see right here, these values are getting further and further away from that x-axis. Well, these values are getting further and further away from the x-axis if I do that. So they're getting away from the pole. If I went this way, well, these are getting closer before they get further, aren't they? So that's why I'm not going to do it that way. Now I'm going to go ahead and do from pi to 3 pi over 2. I went a little too far. But this is what I'm going to have. So at this point right here, my polar coordinate there is -1 3 pi over 2. So -1 3 pi over 2, here's 3 pi over 2, but instead I'm going to be over here because I've got to be at negative for my radius. So that's going to put me here. That's equivalent to 1 pi over 2. And I'm going to go ahead and curve this way like that. All right, and then now I'm going to go ahead and do this last part right here. That's from 3 pi over 2 to 2 pi. So right here, my polar coordinate for this one is 0, 2 pi. Well, 0, 2 pi puts me right back at the pole. And so I've got to curve this way. And again, I know I keep saying it, but I'm going to curve out this way into the pole. If I think about it this way, 3 pi over 2 to 2 pi, that's going to be right over here, right? But I have a negative r value. Negative r value means I'm going to instead be over here because it's on the opposite side because I have a negative r. And now I've got a pretty little limison. So it's a nice little cardioid. So that's what I have for this one. Okay. Hopefully that makes some sense, but I'm going to do some more in another video and we'll go from there.